Hi, good morning, and welcome to the ZP FoodSense webinar. So we like to do this webinar once a week, and it's really part of our support for FoodSense. So we've had some questions come in this week, and I'll essentially jump straight into it. So really, ZP's FoodSense is really about digitization and traceability in the food supply chain. But it's also, it's all hinged on rapid test, and I would say rapid and low cost test. And I think in test, we're really talking about transparency in test as well. And by transparency, if you make a capsaicin measurement on the FoodSense, then you will get a sort of Scoville heat unit measurement. But you'll also, not that you need to look at it, but you'll also get the raw data behind that measurement. And I think that transparency is really important. But you'll see that transparency come up today as well, because the transparency kind of means that we can actually confirm why we say, or why the app says what it says. So today I'm going to talk about measuring chili powders and foods. So every week we do this webinar as part of the support. Every month we do a live streaming webinar, and that's also part of the support as well. We just like to have this kind of constant, once a month people can expect to be able to see a live webinar. Today's question is really about how to measure a 1 million to 5 million Scoville heat unit powder. I should have put the word chili powder in there. And then question number 2, which is the harder one, I would say, is how to measure dry coating ingredients. So I presume somebody's got some sort of coating. It could be breadcrumbs, or it could be some sort of crumbs that get coated on food, and maybe it's got some chilies in it, so it's a bit spicy. That's what it sounds like. The other one as well, frozen vegetable based product. Somebody wants to measure the hotness of that. It sounds more unusual for us, and then the frozen chicken based products as well sounds more unusual for us. But these are today's questions, and I will address them as we go forward now. Support, everyone gets personal online training. So if you're a ZP client, you will get personalized online training. We do these weekly webinars, so questions will come in during the week. For example, today we talk about 1 million and 5 million Scoville heat unit powders, and monthly webinars as well. The FoodSense does, this is generation 4. It's definitely smaller. It's definitely easier to use. It's more accurate, and the accuracy is also backed up by the fact that, if there's something not happening or there's some sort of interference, we can see it in the raw signal. It is cloud enabled. So I've spent, the last sort of 10 days supporting a client in California as they kind of come up the curve and they start becoming a FoodSense user. It is multi-analyte. It can do, today it can do chili, ginger, total antioxidative status, which is listed here as well. It does have some really nice, really modern features. This is the kind of device itself. It's very sort of handheld. The engineer in the top right hand corner, she's actually turning the device on at that point. And I suppose I should say, it's got a series of kind of LEDs at the front, and there's a kind of LED that says the device is on. There's an LED that says waiting for Bluetooth connection. There's an LED that says it goes solid blue when it's got Bluetooth connection. There's an LED that flashes green when the assay is running, and it goes solid green when the data is uploaded, or it goes yellow if the data failed to upload. So it's got a very nice user experience, and the engineer here is just showing she's using her smartphone to actually drive the device. The other video in the bottom left hand here is just saying that we've got this series of QR codes, and you can go between different assays just by scanning a QR code. If you've got your smartphone out and you're watching this, you can find the app on the Play Store. You can obviously pause and rewind. You can also find the app on the App Store. This only works obviously if you're scanning from an iPhone or an iOS device, and the other one only really works if you're coming off a Android device. But that said, the app is out there and it's deployed. We do have these QR codes. This is one for chili, this is one for ginger, and this is one for test. So when you open up the app, it's going to want to know, well, what is it you do want to test? By the way, you don't have to keep on scanning these QR codes. It's essentially a setup thing, and once you've kind of decided upon chili, you can later on go to ginger, for example, but as it is, you just scan the QR codes at the time. So as I say, we do chili and ginger and something called total antioxidative status at the moment. I'm going to jump into the questions now. So question number one was really about how do I measure pretty hot chili powders, considering that pure capsaicin has a hotness of about 16 million Scoville heat units. That's the pure compound. Then 1 million and 5 million are getting pretty hot. I think the hottest chili at the moment is that Pepper X, bred by Ed Curry, and that is about 1.3 million. So I don't know where they're getting these powders from, but there you go. The problem that they have really is, today people are not really accurately able to measure these kind of hotnesses. The HPLC, that's the alternative way for this, is just too expensive. It leads to under testing, and it also leads to slow results. And it's a black box with no sense of error. So what I mean by that is, people get these certificates of analysis, but they kind of mistake a certificate of analysis for an accurate certificate of analysis. There's a difference. You can have a certificate of analysis, but it doesn't make it intrinsically accurate. So people do rather believe these certificates of analysis to say that your powder is this Scoville heat unit. But it's expensive to get hold of. You didn't get more than one test ran at a time on a particular sample. The results can be rather slow, and every result should have an error associated with it. And I think in particular for these hot methods, this is the AOAC official method. They're not actually validated to run particularly hot powders. So, if you look at the AOAC method, and I should say that there's an Indian food, let's say agency or agency for analytical standards in India for the food industry. They also follow the AOAC method. And even though they quote that it could be used for chili powders, in the first paragraph of it does say not applicable to chili powders, so it's kind of ironic. But that said, the AOAC method is A, not validated for chili powders, and B, it's not valid for the range. These people want to go to 1 million, 5 million Scoville heat units. It's not valid for that range. There's a problem when testing hot chilies, hot chilies, hot anything, because capsaicin is not terribly soluble. So if you look at the sort of solubility curve for capsaicin, it dissolves in, but in water. So I sometimes use this term, aqueous. Aqueous is probably just coming from the Latin, aqua. I say aqua. I have to look that up, but it's got a limited solubility. So I kind of have this rule of 500 Scoville heat units. Now, obviously, when you make up chili sauces and chili oils, it's the organic materials like the oils and the fats that help to solubilize the chili. Otherwise, in fact, most of the capsaicin would be insoluble. But we do have this rule of 500. In fact, so what I mean by that is most powders that we get, and here I'm kind of thinking specifically because a lot of this seems to happen in India, particularly on the powder front. You can test them by taking 1 gram of chili powder and dissolve it in 9 mils of buffer. If it's a very mild chili powder, you only have to do what we call a 1 in 10 dilution, but chili powders are sometimes a little bit hotter. We label that vial at 1 in 10 because that sort of tells us that chili powder 1 in 10 dilution. We vortex it for 30 seconds. We take 100 microliters of that, and we then dilute it with 900 microliters of buffer. So we go from a 1 in 10 to really a 1 in 100. We label it, and then actually you could do this a bit more efficiently. We sort of take another 100 microliters and we dissolve that. So we've sort of done a series of dilutions, and then we actually label that and test it. I should have put here that we sort of test it 3 times often, just to make sure that our accuracy is better. And in order to prepare that sample, we needed about 10.8 mils of buffer, 9 mils here, 0.9 mils here, 0.9 mils here. So you can see where I get to my 10.8, or call it 11 mils of buffer. So that's the procedure that we use for most powders. I should have really put here that we test at the end. We end up with a volume of 1 in 1,000 dilution, which is about a 1 milliliter volume. We only need 50 microliters, so we tend to sort of test it 3 times on 3 different sensors and get an average and what's called a standard deviation. Now, when you've got 1 million Scoville heat units, if I remember my rule of 500, I actually have to dilute it to 2,500 times, and that's what I've been helping a client with this week. because then he gets to this kind of magic 500 Scoville heat units. The thing I say is, many chili powders are incorrect. So really, what's really amazing is that when you talk to people, that you find out, well, why do you think it's hot? They actually say, well, I found some, chat rooms on the internet. But there's very actual little evidence of it. It's actually quite, extraordinary actually. So there's, you can get these things quantified either using the FoodSense or using an HPLC. The HPLC, I've got a suspicion, is the expense means that, for example, somebody may have a pallet of chili powder and they may take one sample from that pallet and test it, and then just make the assumption that it represents the entire pallet. But chili powder is actually really heterogeneous, so you can't make that assumption. You have to actually test it a lot more places to understand the range of chili powders within that sample. So we do find ourselves sort of with people sort of having these extraordinary claims about the hotness of their chili powders, and then you actually think, you sort of see the raw data and you think it's not what it says on the label. So I think there's a lot of sort of claims going on, but they're not necessarily backed up by any kind of, or very little scientific or analytical chemical analysis. If you go for 5 million, you have to do a 10,000 dilution to get you to this magic 500 Scoville heat units. Again, I've not really come across a 5 million chili powder. I know capsaicin itself is 16 million. We are able to detect or measure capsaicin, the pure form, but obviously you can do it by just by increasing the dilution. So there's no upper limit for us, in fact, because we just increase the dilution every time, and the software just takes care of the dilution. I've clicked through to question 2 here actually, so let me jump into that now. So question number 2 is, how do I measure dry coating ingredient sample? How do I measure frozen vegetable-based product, frozen chicken-based product? Okay, so I'll give some thoughts and address that question now. Now, with the dry coatings, I'm sort of assuming that actually, that really this is some sort of chili powder that's otherwise mixed with other materials. So it's a kind of, it's a diluted chili powder, if I can call it that. So I'm going to say take 1 gram of the coating and dissolve it in 9 mils of buffer. Now, it's not really going to dissolve. It's just going to get suspended, basically, in there. But we're quite used to that. That's what's quite nice about the FoodSense, is actually we can deal with these kind of suspensions. I would say, label it up dry coating 1 in 10. The reason I say label it up like this is because if you're an actual client of ours, an actual customer of ours, then we're able to support you. And by labeling up this data like this, if we need to support you, it's easier for us to find and understand the data later on. So take 1 gram, put it in 9 mils, label up the vial, vortex it for 30 seconds, take 50 microliters of that and actually test it on a cartridge. Take another 50 microliters of that 1 in 10 and test it. Take another 50 microliters and test it. I should say it's a new cartridge every time. The reason being is when you've got samples that are very heterogeneous, you can't take one measurement and say that's representative of the sample. You actually have to sample it a few times, because a sample taken near a powder will have a different hotness to a sample that's taken from a slightly further away from a powder. It's not homogeneous throughout. The way you get homogeneity is chili sauces, for example, are relatively easier because they're very much chopped up. They've been left soaking for a while. The capsaicin is evenly distributed throughout. But when you've got these more kind of definitely powders, you've definitely got different levels of capsaicin in the sample. So you actually have to sort of sample and test several times. That's why I'm also saying that that's what's wrong with HPLC, because the cost of HPLC, just out of interest, to run the HPLC extraction method takes about 5 hours. So you can see that people just simply can't do the amount of testing that it takes to understand these complex samples. Anyway, that said, they have a dry powder. It seems to be for coating foods. Do a 1 gram in 9 mils, vortex it. Then you can test it 3 times and give it the different label each time. Dry coating 1 in 10 A, dry coating 1 in 10 B, dry coating 1 in 10 C, because that makes it easier for us to later on find the data in Julie and understand what's going on. In order to do that, you just need 9 mils of buffer. take the instrument. Don't forget to choose the 1 in 10 dilution, because that's take the app rather. Don't forget that. And I know what I'm looking for. See, this is when you start to deal with unusual. I wouldn't say unusual, but things that we normally get dealt with or we normally deal with at ZP are chili powder seems to be very common at the moment. Chilies, actual chili peppers, and chili sauces. These are the things. So when you've got an unusual sample, you kind of run it, and you will get a Scoville heat unit on that smart device at that time. But I said it earlier on, when you're running the assay, the front of the machine will flash a green LED. Right, so that tells the assay is running. At the end of the assay, the data goes to the cloud. Now that data is saved behind your username and password, so I can't see it, but you can choose to share it with me. With this particular case, they're going to, because I know the guy very well, he's going to end up sharing it with me, so I know what I'm looking for. I'm looking for, when I look at the raw signal, we're looking for a very distinctive shape of capsaicin. And in particular, then the data gets processed. And I'm looking for this kind of peak here, and I want to look at the height. I'll show you. So I'm looking for this particular thing. This is my kind of quality control, make sure everything's kind of working all right. What I want to see is sort of, is a series of curves, and the system does this anyway, and will give you a Scoville heat unit. But then, if you want a sort of senior guy like myself to step in, we can, we know what we're looking for. We're looking for piece of data that looks like this, a piece of data that looks like this, and then a piece of data at the end that looks like this. So that tells me that everything's working okay. What I might want to look out for is this. If I see this, and what I mean by this, what's happened here is the person's tested 1 million Scoville heat unit powder at a 1 in 10 dilution. So they've kind of broken our 500 rule, because 1 in 10 dilution means that they're really at about 100,000. It's out of scale here, it's cut off, and it's also out of scale here, it's cut off. So I know what I'm looking for, and then we can so essentially make sure that things are okay. By the way, if this does happen, the software will report, or not, the app will report it's under diluted, so you don't just not know, it does actually tell you. But somebody like me comes in, we have a look at that, we say, right, it's just not diluted enough. So that's kind of not diluted enough. There's another case where this is a mild chili powder that was tested in 1 in 1,000. It still runs, but the signal that we're really looking for is down here, and it's just really, I can just about see it. So we can report this, but to increase the accuracy, we may actually suggest them they do a 1 in 100. So because the dry coating is unknown to us, I think it's going to be quite mild. We're suggesting a 1 in 10 dilution, and then you can upload the data. But when you upload the data, understand that actually then somebody like myself can actually look at the data later on and write a report about how, were you in range, let's say. And if you need to dilute more, then take that 1 in 10 dilution, take 100 microliters of it, dissolve it in 900 microliters of buffer, label it, vortex, and then test it 3 times, label it A, label it B, and label it C. Make sure it's a fresh cartridge with a fresh 50 microliters for each particular test. Just trying to get an understanding of the true concentration. This is because within HPLC, what happens is they just do one measurement. Well, really, they need to do a couple more measurements and actually do the average and standard deviation, but they don't because it's too flipping expensive to do, so they don't. So let's have a look at the recap of the questions. Question number 1, how to measure, or recap on this question, how to measure dry coating ingredients. Do a 1 in 10 dilution, vortex it, take 1 gram, vortex it in 9 mils, and essentially test it. Make sure the data goes to the cloud, and if it looks like it's too much, it's still too hot, then you'll dilute that down to 1 in 100. I think at that point you should be okay. I'm going to deal with frozen vegetables, and I'm going to deal with frozen chicken-based products at the moment. Frozen vegetables and frozen chicken-based products. Like I say, I'll say it again, but most of what's happening at the moment, most people are testing. In India, it's mostly chili powders. In other parts of the world, they then tend to test the sauces because they've taken the powders in and they've made the sauces. And we're also helping people with chilies themselves. But the chili, the frozen products, interesting actually, because I think, let me just check something. Yeah, All right, so sample prep. I just want to talk about sample prep because I do want to I'm trying to deal with that frozen vegetable and frozen chicken question. So when we have a chili pepper, we essentially chop it up because we want to chop it up to increase the surface area. Because what we want is the capsaicin. In order to get the capsaicin, in order to do an extraction, the finer you make the particles, the higher their surface area and the easier it is to extract. So when you talk about frozen chicken and you talk about frozen vegetables, it's for us the more it's chopped up and the more surface area it is, then the more extraction there is. So there can be quite. It sounds to me like there could be quite a bit of sample prep. The one thing to say is every time you do a manual effort, you can be, in preparing that sample, you can be the source of error. It doesn't matter if you're testing on HPLC or on the FoodSense. You're doing a manual process. You are the source of error. So, you can have error due to sample prep. But you have to chop it up and get as much surface area as possible. At which point then, I think the first stage of this is take that 1 gram and put it in 9 milliliters of the buffer and vortex it like crazy. The chicken feels even harder, but you're going to have to sort of chop it up and increase the surface area as much as possible, and then you can start the 1 gram in 9 mils extraction. But you are now stepping into more complicated samples, and that's why it's important that actually we do have this online system. The data goes to the cloud because, we can look at it and say, are there interferences? Is the capsaicin too hot? Is it actually too diluted? And how to kind of get the signal back up. Because the way I feel about it a little bit, that if it's on chicken, it's probably on the coating or on the skin of the chicken. So you've got, a sort of, some grams of chicken meat, then with a thin coating around it. By the time you blend all that up, you've actually diluted the capsaicin down quite a lot. But you may just want to test the skin itself, actually, where the capsaicin is at its essentially hottest. So most of the time we're dealing with chilies, we also deal with powders, and we deal with sauces. These frozen materials do sound a little bit more unusual. Don't forget, I'm just wrapping up now, that there is the FoodSense demo, live streaming demo every month. There's one on the 25th of January. I should have said that if you see any kind of link today, I'll make sure I put that underneath the video at the end. And I want to say thank you. So yeah, everyone who's a customer gets online training, online support. Everyone who's anyone who's interested, we have these weekly webinars and we answer questions there. And don't forget, we do have these monthly webinars. The next one's on the 25th of January. Okay, thanks very much.